Good morning, my dear students. I hope everybody is doing great. Let us continue the session called dimensional formulae. So many dimensional formulae we had learnt so far from your known physical quantities. So the major problem faced by most of the students in first PUC in this chapter especially is, the name of the chapter is units and measurements. Units. Unit will be there for any physical quantity, for most of the physical quantities you take in physics. Some of the quantities you will be learning and you will be introduced in this chapter from second PUC topics even. I hope you're getting the point. From second PUC topics also, there are some physical quantities will be introduced here. Just a quantity and its formula. Because you're going to write your NEET or JEE or CET examination after 12th. Clear? After 11th class, you're not going to write any exam. After 12th. And in these units and dimensions, we'll be introducing few physical quantities which are having connection with your second PUC topics. It doesn't mean that they are completely new to you. No. You might have learned them in your 10th standard or in 9th standard. Only few topics will be introduced newly to you now, but not the topic. Just the unit and its dimensional formula. Because we cannot leave them. In most of the NEET exam, JEE exam, CET exams, these questions were asked. Clear? When a particular physical quantity comes into the first PUC or second PUC topic, and we will be discussing in detail about that. And remember, minimum 1 mark and minimum 1 question and maximum 2 questions will be directly or indirectly asked from this topic called a dimensional formula or units and measurements. So to get full marks in this chapter, what you have to do is, from now, whatever the physical quantity you have seen in a chapter or a topic, try to write the dimensional formula there itself. You will be having almost 30 chapters in physics starting from first PUC until the end of second PUC. Out of these 30 chapters, whatever the physical quantity appears to you, start writing its dimensional formula. Then you will get a maximum 8 marks and minimum 4 marks out of your physics 180 marks. Right? I hope it's very clear to you, and let's start the class. Some more dimensional formulae and quantities with similar dimensional formula. 90% of the cases, the questions asked in your NEET exam based on this topic will be here. Quantities with similar dimensional formula. Identify the set of physical quantities among the 4 options. Which quantity set is having the same dimensional formula? Like that the questions will be asked. Let's see. I have written 9 physical quantities here and their dimensional formulas also. And do not get confused. I am going to derive each and every dimensional formula here. Each and every dimensional formula here. No worries. Okay? Clear? Let's start. Density. You know the density. So, one by one. Number 1. Density is what? Density D is equal to mass by volume. Okay? Mass. Dimensional formula is M by volume. Dimensional formula is L cube. So, you know it is ml minus 3. So, that is density. Clear? So, why there is no T here? So, this density is independent of the time. Okay. Number 2, what is that? Relative density. You know what is meant by the relative density? In the ninth standard, you might have learned a chapter called gravitation in brackets flotation. There, the first time relative density term will be introduced to the ninth standard students. So the relative density is equal to density of the substance divided by density of the water at 4 degrees Celsius. Why only at 4 degrees Celsius? So that's another topic. Density of the substance. What is the density of the substance? Dimensional formula ml minus 3 divided by density of the water, dimensional formula ml minus 3. So finally, both these will be cancelled and you get the dimensional formula M0 L0 T0. Not only this, any physical quantity is having the numerator and denominator same dimensional formula, and your final dimensional formula of that will be 0, M0, L0, T0. For example, I'll give you another physical quantity here. Here itself, refractive index. What is that? Refractive index. Refractive index means what? Refractive index means what? Refractive index is equal to sin I by sin R. I hope you remember the situation. Refractive index. So I'm writing here N is equal to sin angle by sin R. In 10th standard, in refraction topic, you have sin I by sin R. Sin I, it is an angle. I told you while discussing the plane angle topic, theta is equal to L by R. Length dimensions are L, R. Radius dimensions are L. So, angle will not have any dimensions. Understand? So, here you can also include angle. Any angle you take, there is no dimensions. So, no dimensions and no dimensions. Or you can say it is an angle, it is an angle. Numerator and denominator both are angles only. Units will be cancelled. So, this refractive index also will have M0, L0, T0. Angle will have M0, L0, T0. And most of the relative terms, relative mass, relative height, relative density, right? A relative velocity. So, all these cases. Understand? We have M0, L0, T0. Now, next one. And the questions will be asked in this way. Which among the following set of quantities will have the similar dimensions or dimensionless? This is dimensionless, relative density. Refractive index, dimensionless. Angle, dimensionless. Like these questions will be asked. Are you ready? Ready to do the third physical quantity dimensional formula. Number 3. Energy density. This is completely 100%. It's a new concept, a new physical quantity for you, right? So number 3 is energy density. Energy density is equal to energy per unit volume. What is it? Energy per unit volume. And what is dimensional formula of energy? That may be the potential energy or kinetic energy or mechanical energy or any type of energy you take in the nature. Understand? Any type of energy you take in the nature, and it will have the dimensional formula. Same. Or last class you have done on your own the energy dimensional formula. I am writing here energy dimensional formula is ml square and T minus 2. Divided by volume. What is volume? L cube. So this is L square cancelled. Finally, M L minus 1 T minus 2. So that is the energy density dimensional formula. What is energy density here? Energy per unit volume. Remember, energy per unit volume is energy density. Generally, Mass density is mass per unit volume. This is the density. You know what is actually the density? That is called mass density. So that's the reason it's mass per unit volume. Energy density, energy per unit volume. Clear? Now, fourth quantity is a pressure. You know the pressure dimensions, you already know it's force per unit area. What is force? mLT minus 2 by area is L square. So 1L cancel and it will be mL minus 1 T minus 2. Can I say the energy density and the pressure dimensions are same? Carefully look at the situation. Energy density dimensional formula is mL minus 1T minus 2. In the same way, pressure dimension is mL minus 1 T minus 2. Okay. Clear? Come back to the fifth physical quantity, what I have written here. The fifth one is stress. You know, the stress is also written as force per unit area only. This will be the new physical quantity for you now, but once you start the first PUC, in the middle of the first PUC syllabus, you get a physical quantity called stress. Okay? Stress. Force per unit. And this stress formula and the pressure formula is same. When this is force and area, when this is also force and area, definitely its dimensional formula is same. mL minus 1, T minus 2. And the sixth physical quantity you see here, sixth physical quantity. And 99% of the cases, if the question to be asked from the dimensional formula, the question will be asked from this area. Even in some competitive exams, for job-oriented I'm talking about, for job-oriented competitive exams also, the basic science questions will be asked, and this is the most important question there itself, there even. Young's modulus or bulk modulus or modulus of elasticity, whatever may be the name, the dimensional formula will be same. What is that? Dimensional formula will be same. Clear? And remember, this Young's modulus, bulk modulus or modulus of elasticity, I am just representing with the symbol Y. Y is Young's modulus or bulk modulus or modulus of elasticity. And just for name's sake, I am just giving you as Y. You know the formula for this? The formula for this is stress by strain. Stress by strain. You know what is the strain? The strain is equal to change in length by original length. What is strain? Strain. Change in length by original length. And most of the places, wherever there is a stress terminology you study in physics, and there will be strain is also followed by. Stress is force per unit area. Strain is change in length by original length. Change in length by original length. So my dear students, I am thinking that you are understanding each and every moment of the class. Strain is change in length by original length. So this is the length and this is also length. Will there be any dimensional formula for the strain? No, because numerator and denominator is having same physical quantities. Numerator and denominator is having same physical quantities. Okay. Numerator angle you consider. Numerator and denominator is having same physical quantities. No unit. So can I include this strain here? Here? Strain here? No dimensional formula. Relative density, refractive index, angle, strain. No dimensional formula. M0, L0, T0. So when this is not having dimensional formula in Young's modulus, whereas stress is having dimensional formula ml minus 1 T minus 2, and this is the dimensional formula of Young's modulus of elasticity or bulk modulus or modulus of elasticity. I hope you understand. Energy density, pressure, stress, Y, all these four are having same dimensional formula, like these questions will be asked. Which among the following quantities will have the same dimensional formula? Energy density, pressure, stress, Young's modulus. Which among the following quantities will not have any dimensions? Angle, refractive index, relative density, strain. Here it's 4 are here and 4 are here. Clear? Sure? Come back here. Acceleration. Acceleration, you know the acceleration A is equal to change in velocity by time, and you have mlt, m0 lt minus 2. The last class we have done acceleration. And acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity is also an acceleration, right? So this will be m0 lt minus 2. This is also an acceleration. Okay. Look at here. Gravitational field intensity. Maybe a new terminology for you. Intensity, I can say generally speaking, intensity means the strength. So it's called gravitational field strength. You have the chapter called gravitation, but that's not exactly first PUC topic in 9th standard. Yes or no? There are some basics in 9th standard. When you go in deep, this kind of physical quantities will come across. What is that? A gravitational field intensity. Okay. It is denoted with the symbol I is equal to F by m. What is this? You know, this is gravitational force per mass. What is the formula for gravitational field intensity? Gravitational force per mass. Force mlt minus 2 by mass. What is that? What is this? M cancel, right? Lt minus 2. So Lt minus 2 is the acceleration. Lt minus 2 is the similar with the acceleration due to gravity also. So which among the following quantities will have the same dimensions like acceleration? Acceleration due to gravity, gravitational field intensity, and no confusions at all. My dear students, look at the topic. How we have discussed the basics and how we are moving into the first PUC portion slowly and slowly. Right? This actual exclusive first PUC topic it is. Okay? Just pause the video, practice all these physical quantities, and we'll be moving to the next more and more physical quantities. Here, some more dimensional formulae. Right? We'll be doing some more dimensional formulae now, along with this topic called quantities with similar dimensional formulae. My dear students, I believe in you that you have practiced the previous 9 physical quantities and their dimensional formula. You might have observed the similar dimensional formula among some physical quantities. And some physical quantities are not having any dimensional formula. They are called dimensionless quantities. Alright, let's begin. The 10th physical quantity. The quantity number 10 is momentum. We have already discussed momentum is equal to mass into velocity. Mass dimensions are m and the velocity dimensions are lt minus 1, and mlt minus 1 is the dimensional formula. Impulse. This also we had learned. Impulse is equal to force into time. Force mlt minus 2 into time t. So what I can write? ml t minus 2 plus 1. So finally it will be mlt minus 1. No confusions at all. Do not ask me a question that how this will be minus 2 plus 1. We are just multiplicating the two physical quantities which are having the powers. It is 2, 1. Alright. So how you will be multiplying these two? The powers will be added, right? So powers are added like this. So these two physical quantities are having the same dimensions. You can see mlt minus 1, momentum and impulse. Okay. Alright. Moment of force. The 12th physical quantity I have taken is force, you know. Moment of force we do. The 12th physical quantity, 11th one, okay. Moment of force, which is equal to force into distance. Remember, distance are some length. Force here it is there. We have just added moment. So this quantity must be multiplied with length. So that's called moment of force. Right? Understand? If I write moment of momentum, momentum will be length. For example, simple example I am giving. Moment of momentum. Any physical quantity, moment, if you add, whatever the quantity we have, momentum, which must be multiplied with some length. That's it. Moment of moment. Clear? Moment of force. Force into length. So let's come back to the dimensions here. Force dimensions are mlt minus 2 into length, right? So into length. So that will be ml square t minus 2. So what is the dimensional formula of moment of force? It will be ml square t minus 2. The moment of force is also called as couple. And this moment of force is also called as torque, which is the most important physical quantity in rotatory motion. In what? In rotatory motion. And let me write somewhere here. In rotatory motion, the most important physical quantity you will be learning is about torque. Not only in rotatory motion, in electric charge, in electric field we will be using this. In magnetic field topics also it will come. Moment of force, couple or torque. So till now you have the dimensional formula of this ml square t minus 2. Here also it is written. And work. You know, work dimensional formula is also same. ml square t minus 2. So many times we had written so far. And you have all the energies. See, work will have the same. Energy will have the same dimensional formula. And even torque will have the same dimensional formula. It's no problem at all. Is it clear? Is it clear? My dear students, our major focus for this session is the quantities with similar dimensional formula. Clear? Let's see the fifth one. 15th one. Force constant or spring constant or surface tension. Force constant, spring constant or surface tension. Whatever it may be. So the 15th one I am talking about, its formula will be force per unit length. What is that? Force per unit length. Let me write it is force and it is length. So force per length, force mlt minus 2 by length L. So what do you get? mt minus 2 and L will be 0. No confusions. ml 0 t minus 2. See here, ml 0 t minus 2. Force constant, spring constant, surface tension. Three physical quantities are completely new to you, but don't worry. We are here to support you from the day 1 to the day end. Okay? Clear? I have told you clearly during the starting of this session, starting of the today's session. In this chapter, as the name of the chapter is units. But we must not stop our learning with the quantities what you already know. We should go beyond. We should go extra mile. Understand? To learn the new physical quantities. But We are not going to deep. In deep analysis of force constant, spring constant, surface tension, we have not done it. Clear? Just it is spring constant, force constant, surface tension formula will be force per unit length, and that force per unit length dimensional formula you get like this, right? All these three physical quantities will have the same dimensional formula. All these three physical quantities will have the same dimensional formula. All these two physical quantities will have the same dimensional formula. Alright. 16, 17, 18, I have not written any dimensional formula here. Why? Let's see. Before moving to the 16, let's start with 18, electric current. Why I am starting with 18? Because electric current is one of the fundamental physical quantities in physics. Yes or no? One of the fundamental physical quantities is electric current, and its dimensional formula directly we can write. What is its dimensional formula? Electric current. So I in square brackets, I R in square brackets, A, ampere. Anything you can use, no problem. Now come to the concept called electric charge. So 16th physical quantity I am taking, electric charge, which is denoted with the symbol Q, which is equal to, what is the formula for electric charge? Q. Electric charge, Q is equal to electric current into time. Q is equal to IT. I is equal to Q by T. Okay. From electric current, see, I is equal to Q by T. Okay. So, what is our aim? Our aim is to find electric charge dimensional formula. Electric charge is equal to, dimensional formula of electric charge is equal to I. I is what? Ampere. A into T. T is, okay. So the dimensional formula is A T. A is ampere, T is time dimensional formula. Alright? Current dimensional formula is A and time dimensional formula is T. And number 17. 17 is magnetic field. We have the magnetic field formula. What is that? Magnetic field is denoted with the symbol is what? B. I told you, to write any dimensional formula, the first basic requirement you must have is formula you should know. To write any dimensional formula you should know. That's what we started with. Speed, distance by time. Without knowing distance by time is equal to speed, you cannot write the dimensional formula. Nobody can do anything in this case. If you are unable to recollect the formula or learn the formula behind a physical quantity, a physical formula behind a physical quantity, 100% you cannot write the dimensional formula. Magnetic field. In your 10th standard, you must have learned the magnetic field with this. Magnetic force is equal to QVB. What is this F? Magnetic force. I am writing here. What is this F? Magnetic force. What is this Q? Electric charge. What is this V? Velocity. So what is the B? Magnetic field. Already we have here. So B is magnetic field. Okay. Now from here what you can write? B is equal to F by QV. For example, if you could not recollect from your 10th standard basics and learn now, but we are not going into the deep, just F is equal to QVB. That's a magnetic force formula. And B is equal to F by QV. What is the force dimension? Whatever may be the force, it may be electric force, magnetic force, any force you can consider. F is equal to MLT minus 2. That is the force dimension. And charge dimension you have already. Charge, electric charge dimension. What is that? A into T. So A into T is the charge dimension into velocity. Velocity dimensions are LT minus 1. Okay. Simple. L cancel. So here what I can write, N. So this A goes to the numerator. It will be A minus 1. And here T t minus 2, and this is t power 1. It comes to the numerator, it will be minus 1, and this t minus 1, when it comes to the numerator, it will be plus 1. Okay, so here you can write the dimensions. What is that? M a minus 1, and here t minus 2 minus 1 plus 1. Minus 1 plus 1 cancel, and it will be t minus 2. So the dimensional formula of magnetic field is what? Dimensional formula of magnetic field is what? I'm not talking about magnetic force, because magnetic force dimension will be equal to force, general force dimension. Magnetic field dimension will be m a minus 1 t minus 2. Right? How many physical quantities we have discussed? 17, 18 physical quantities we have learned so far, and don't think that the duration of the class is very less. I hope you understand each and every point. So you will be having, you will be required a lot of time to practice all these physical quantities, because some of the physical quantities, I'm not saying all the physical quantities, some of the physical quantities are new to you. Focus more time on them. That's it, right? Just pause the video and practice all those physical quantities and get ready for your 10-question assignment. Take your own time to solve the assignment, right? Own time means it's not like 1 hour or 2 hours. Whatever is the stipulated time is available, take that particular maximum time and do the assignment very well, and take care about your negative marks. Thank you so much.